Let us continue learning something more about the crystal structure. In this lecture, I will be concentrating on Bragg's law and few problems. Bragg's law is stated that when a beam of X-rays is incident at an angle, let us say it is theta, with respect to a family of crystal planes of interplanar distance d, the X-rays scattered by the atoms in the planes undergo constructive interference if the path difference is n lambda equal to 2d sin theta. Here n is the order of diffraction. In our previous discussions, I have told you that it is possible to imagine a number of planes within a given crystal system, but that plane has to pass through the atoms or the lattice points. Such planes are also known as the Bragg planes, and we have learned them. And here the Bragg's law talks about the condition for X-rays to undergo diffraction by a crystal system. The purpose of taking X-rays is that the crystals can effectively diffract the X-rays. You have learned from the physical optics that the diffraction is a phenomenon of bending of a beam of light towards the geometrical shadow. And you had learned that a condition for diffraction is that the dimension of the obstacle that is diffracting the light should be equal to or closer to the wavelength of that radiation. So the wavelength of the diffracting beam and the size of the obstacle should be comparable. That is the basic condition for effective diffraction. X-rays are basically very short wavelength radiations. The wavelength may be of the order of 1 angstrom or 0.1 angstrom. That much short wavelength is there. If the wavelength is very short, it is impossible to use the obstacles which we observe. We can say that they are the observable objects. So observable objects will have the size of the order of, we can say, millimeter or in order of centimeter or more than that, so that those sizes are very high. Such sizes or the obstacles are not suitable for diffracting X-rays. And by diffracting X-rays by a crystal system, it is possible to study some properties of the materials. The crystal arrangement decides a number of properties. That's why it is very essential to study the properties of materials that are developed. So nowadays in the research field, X-ray diffraction technique has become an essential component or characterization technique in studying the materials characteristics, so that it is very necessary for you to understand the diffraction of X-rays. But for diffracting the X-rays, as I mentioned, we need an obstacle having the size of the order of the wavelength of X-rays. But the objects which we have around us do not have that much small size. The atoms have that much size. The atoms that are arranged in a crystal system can act as the obstacle for diffracting X-rays. That is the reason why we talk about the diffraction of X-rays by the the crystal systems. Bragg had given a statement in terms of a law which is known as the Bragg's law. According to him, if a system of atoms have to diffract the X-rays, then they have to satisfy a condition given by n lambda is equal to 2d sin theta, and if that condition is satisfied, the diffracted rays will undergo constructive interference and gives rise to high intensity radiations, which is required for our studies. So that he stated that when the beam of X-rays is incident at a specific angle of diffraction theta with respect to a family of a crystal planes, then the scattered X-rays will undergo constructive interference if the path difference is equal to n lambda. That is the condition for constructive interference, which we understood through the physical optics during our earlier courses, and that n lambda should be equal to 2d sine theta according to Bragg. Here d means it is the interplanar distance. For example, if this is a plane system, this is interplanar distance. This is also the interplanar distance, and this is a plane. These are a number of planes available within the crystal system, right? And in order to derive this expression, we need this diagram, and in this diagram you can observe that a beam of X-ray is made to incident on the Bragg plane. These are the crystal planes, and on this crystal plane a beam of X-ray is made to incident so that it gets scattered. Later we will understand that it is diffracted, and one more X-ray which is parallel to the previous ray is also getting scattered by another atom in the other plane which is parallel to the first plane. The angle of incidence is different. For example, this is the normal drawn to the plane. This is known as the angle of incidence, but this is the actual angle of glancing angle. This is known as the glancing angle. That is the angle made by the incident X-ray with the plane. It is not the angle of incidence, it is the glancing angle, and that glancing angle is required for our calculation. And here the interplanar distance is taken to be d. This is already shown somewhere here. Yeah, it is shown here. This two light rays, X-rays are diffracted or scattered. Let us say scattered or diffracted. Both are this similar phenomena here. So the diffracted beams are moving towards C here and F in the other case. You draw the perpendicular to this particular beam, another perpendicular on the other side, BP and BQ, and they can make an angle theta with respect to the line that joins the two planes. This one, this line and this perpendicular are making an angle theta. If that is the case, then you can calculate sine theta from this equation. You can have an expression for sine theta. What is sine theta? Sine theta is given by, okay, it goes to the next slide. Okay, before going to that, let me complete what actually the condition for constructive interference. I was mentioning in the previous slide that the physical optics gives us an idea that if the two light rays have to undergo constructive interference, then the path difference between the two rays undergoing interference must have the path difference equal to n lambda. So path difference should be integer multiple of the wavelength of the beams that are undergoing the interference. And for destructive interference, you knew that 2n plus 1 into lambda by 2. That is the condition for destructive interference. Okay, here it is not required. So we are concentrating on the constructive interference because that gives rise to higher intensity. So basically path difference should be n lambda. What is path difference? Path difference is the difference in the paths traversed by the two rays which are undergoing interference. For example, this light ray ABC, that is the path traversed by the first light ray, X-ray, not light ray, X-ray, and DEF. Since this is the ray which is penetrating little deeper into the crystal, it travels more distance. That is why If you think they are originated from the same point, you can observe here that this line and this line have the equal length. This is the additional distance. Okay, this is the additional distance traveled by this X-ray, and this is the additional distance traveled by the scattered X-ray. Therefore, total extra distance traveled is PE plus EQ. That is the path difference between these two X-rays. Hence, it is given as PE plus EQ here. Right. That is about the path difference. And now I was telling you in the beginning that sin theta is required to be calculated. Sin theta means what? It is opposite divided by hypotenuse. In this triangle BPE, sin theta means what it is? This is theta. Opposite to it is PE. Hypotenuse is BE. Therefore, opposite is PE divided by BE gives you sin theta. Similarly, from the other one, means from this triangle BQE, you can get one more sin theta. Sin theta is equal to opposite, that is QE divided by BQ. That is what I have written here. Sin theta is PE by BE. PE divided by BE. This opposite and this hypotenuse. And another triangle gives you, another triangle also gives you sin theta is equal to QE, this one opposite, divided by BE, hypotenuse. Here I was rearranging the equation. PE equal to BE sin theta. BE is taken as D. Why? Because this is the distance. BE represents the distance between the two planes, this plane and this plane. So this distance is taken as D. So BE is equal to D. That's the reason why it is taken to be D sin theta. Similarly, in this case, QE is equal to BE sin theta from this equation, and BE means again D. Therefore, D sin theta. And what is path difference? It was told you that PE plus QE. What PE? What is PE? We have PE equal to D sin theta. What is QE? That is also D sin theta. Substitute. You are getting D sin theta plus D sin theta. Totally 2D sin theta, that is path difference. And what is basic definition of path difference? It is n lambda according to physical optics. And we are getting n lambda equal to 2D sin theta because of this reason. This is how to obtain the expression for the Bragg's law.